So basically we've done all the calculus. We're just going to manipulate Taylor series at this point, create new Taylor series with what we know. Okay, so we use derivatives, integrals, and algebra to create new Taylor series. Okay? So what's the Taylor series for, or the MacDaddy series, I guess we could call it, the Maclaurin series for e to the x because it's centered at 0?
10 over n.
Well, let's bring out our cards.
Yeah, it's fine right now. Just know that by Tuesday you're going to want to have those. You can generate these too, right?
Look, it's right there.
You could do first derivative, second derivative, third derivative, all that stuff and generate this. Do you want me to go through that with you, or you good on Taylor polynomials? It's is that right?
Yeah.
Okay, which is the same as? Is it?
It should be
Oh,
pluses.
it's plus. Okay, correct me if I'm wrong. Good? Okay, so you might encounter a problem that says, what is the Taylor series centered at 0 for e to the x? Boom. Okay?
Just that?
Yep. Okay, so this is the Taylor series.
Can we point to that viewer like on the effort?
I don't know.
So all the ones we wrote down today are Taylor series?
It's centered at 0. Yeah.
McLaurin series.
Okay, they're Maclaurin series if you want to get into it. The way math usually works is they'll invent something specific like a Maclaurin series where everything's centered at 0, and then somebody will generalize it to everything else, like a Taylor series centered at anywhere. Okay. Usually the one that generalizes it gets all the credit. That's why they always say Taylor series centered at 0. Okay, so calculate x squared e to the x as a Taylor series. Or calculate the Taylor series 4, right? What do you think you could do?
X squared and crap.
Yeah, multiply, right? Okay. And you actually have to do the multiplication here, so just distribute, right? Algebra. Oop, don't need that. And it'll always say, you'll always get an indicator like the first 3 terms. Okay, so that would be the first 3 terms, right? Or you could also be asked the 4th degree. Okay, and you'd stop whenever it tells you to stop. Okay. That's easy enough, right? Okay, what about, I think we already went over this. Whoa. Okay, straighten your mind out. 4 sine x squared centered at 0.
You're also supposed to count the e to x when you put x squared.
No. A little different. What's sine x?
That's a good question.
X minus,
Oh, then we're going to do the general term.
don't need it.
I wish you
But if you want, we can write it out, just to get the practice. What's the general term?
It's
Because I don't memorize the general terms.
-1 to the n, x to the 2n plus 1 over 2n plus 1 factorial.
N equals 0? Okay, there's a general term if you want to memorize that, fine. Okay, so there's sine x, right? What is going to be sine x squared?
Let's see, you just input x squared instead of x.
Yeah, it's a composition of functions. So we're going to insert x squared into each one. Not multiply, but insert it. What's
Can we just leave it like that, or do we have to?
You can.
Okay.
Yeah, perfectly legitimate. Yeah, if you want to, you can x to the 6th, x to the 10th, right? But again, very, very straightforward manipulation, right? Usually they'll have you write this out, sine x, so what's the Taylor series for sine x? What's the Taylor series for sine x squared? Very, very, very straightforward. Yeah, me too. It's a good finisher for this unit because it's been so difficult.
What's the most change you've seen in like
That's that.
like a substitution in like
Oh, here's a good one. This is probably the let me see how they write this. Okay, write out the terms. Up to degree 5 of the MacDaddy series for, and you can do anything here, but we'll just use these two. Yeah. So let's do this one. What's the series for e to the x? Okay, notice it says degree 5, right? So I'm going to go to degree 5. Just thinking ahead. Okay, that's e to the x, right? Again, correct me if I'm wrong. Okay, what's cosine x?
1 minus x or squared. Plus
Probably don't need that one, right? Oops. Oh, how about that?
Only for the 5th degree, right?
Yeah, so we probably don't need the x to the 6th.
Okay.
How would you solve that problem? How would you simplify this?
ignore it.
Nope, that doesn't make it more simple. The Norton problems usually makes them harder in the end.
Can you just cancel out?
It's a big foiling problem. Gross, I know. Okay, so basically what I advise, take the first term and multiply it by each of these up to degree 5. Right, so we're going to end up with 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, right? Okay, next one.
Can we write it under all these?
Because that's, yeah,
Can we just skip this part then, because we know how to fold?
Okay, plus x minus x cubed over 2 factorial plus x to the 5th over 4 factorial, right? Now I'm at degree 5, I can stop,
Oh, okay.
right?
You can stop there, that's good.
Because if I did this, it'd be x to the 7th, which is degree 7, I don't need it, correct? Okay, now, do I need to do x squared with x to the 4th?
No.
I do not. So it does get shorter, but now I'm going to have plus,
Wait, why don't you need to do this x to the 4th?
Because it would be 6. And yeah, it only goes to 5.
Oh, okay. Now I got it.
Oh, what?
right, so you have x squared over 2 factorial times x squared over 2 factorial, right? X to the 4th over, I can to write it however you want. But I don't need to do this one because squared times the 4th, this is going to be x to the 6th, which is not degree 5, okay?
The degree is determined by the
Exponent, right? Okay. How about this one? Has to be those two, right? Minus. Yeah, they're long problems, right? Are they hard?
No.
No. Let's thank our maker that they are not hard. Okay. One more, I think, yeah. Oh, what color? My amount of colors.
You dotted the
Let's go magenta.
Orange. Okay, so I need that one with that, right? Can I do any more?
No.
I can't. No, because that would make it x to the 6th. So plus x to the 4th over 4 factorial, and then I also have to do
Yeah, that one.
those two. Woo!
That was a lot.
Y'all gonna lose your minds. Up in here, up in here. Woo. Okay.
In parentheses, and it's 2x.
Now combine like terms. Is there another numeric answer? No. How about x squareds?
Yeah, you probably know.
Oh, hey, look at that. Is that it?
But you have X just by itself.
Way.
Is there an x?
Yeah.
Okay, is there any others? No.
4,
Okay, and then x cubed?
just 1. Well, I lied.
Wait, I get that. Does it matter that one's
Then one is
two
cancel a little
factorial
bit.
instead of 3 factorial?
Well, yeah, it's a common denominator of 2 or 6. Right, so this is x cubed over 6. This is negative 3x cubed over 6, right? If you common denominators. So what do we end up with? Negative 2x cubed over 6, which is negative x cubed over 3. You do the fraction reduction. Okay. So we're done with those. Now we need to do the fourths. Let's see a different color. 4 times 3 times 2 is 24.
So glad I was using this math as a freshman. We died.
All right, so we need a common denominator 24, but make that 6. So we have 1 minus 6, negative 5, plus 1, negative 4, over 24. Right? Okay, you get the idea. And we can do the fifths now. Okay, so this is, 5 factorial, 120.
So really, you just hope that you don't get two of these together.
Yeah, it's only giving me half the page.
So we need,
You need to spread out.
that will be 5 and 1/20. This would be negative 10 1/20,
Mr. Arthur.
right?
Why are we doing the factorial simplification? This is a free response, wouldn't it?
Yeah, I know.
Oh, so if this wasn't a free response, we could simplify it?
If this was, we could leave it up.
Or would it be better if we just simplify it?
I'm gonna have to look it up. I think, I'm not gonna talk, because I might screw it up. I'll have to look that up.
Yeah.
In here, again, when you're practicing these, let's always simplify just to practice, right? That 5 minus 10 is negative 5 plus 1, negative 4 over 120, which is done, right?
This looks like a problem we skip in the
This is not a problem you skip because it's easy.
I know.
We need a
So
Jimmy
long.
Charles.
Okay. And then if you want, label it Taylor Series 3-5.
Say about 5 minutes.
E to the X comes
40 minutes, quiz minutes, other slow experiments, 40 minutes, time on your graduation.
Okay, you okay with that one?
That could be in the second.
All right. Last one. Let's write out the first 4 terms
Nope.
of the Maclaurin series for that piece.
That's brilliant. I have fun names
Don't you just write out the
You write out-
and then square it?
You write out
Or no,
one
you
minus
don't
X
square it.
twice.
There are a few ways to handle this. Yeah. Okay. I hadn't thought of that one, Danielle, but I'm pretty sure it's okay to take this.
You just get X there. Squared it.
Which again gets us back to that mess, because you're going to end up with 1 minus x and 1 minus x, and then you have to shuffle. Okay, so very, very good option. Okay, can you think of another? Is there a relationship between this series that you know and that series you're trying to generate? What's the derivative of this? Is it that? Correct? If you derive this with the power rule, or chain rule, you're going to end up with that. So if I put this up here, what's the expansion for 1 over 1 minus x? Yep, you're right, Wyatt. Right? So if I want to generate this here, all I have to do is differentiate. A little easier, right? Nothing. 1 plus Tell me when to stop.
Right there.
Keep doing that. Stop it. Okay, so which one's easier? Binomial expansion or derivative? This is easy.
You know how to try.
We try to keep it simple, but yeah, your first thought was perfectly legitimate, just made your life a little more difficult. You can do the same thing with integrals if you have two, like if you have cosine, what's the integral of cosine? Sine. So if you want, you can just memorize sine and use the derivative to generate cosine. But that's up to you, okay? Any questions? That's all I got. Okay. We will talk test review tomorrow. Friday I'll be around, but I'll have something for you to do because I'll have sub. I have some things to take care of, and
If you were here Friday, like when the clouds were raining, you take
I could be here if you guys want me to. Like,
Both of you on.
like I could be in here. I'll be around, like I said. I could be in here if you want me to be in here. And check in with you.
Sure.
Okay.
Play by
I'll
ear.
check in. If you guys have any questions, I can probably stay to answer.
What are the answers?
Well, if you hear crying, then it's probably safe that.
If you hear, well, let me turn this off first.